Good morning, everyone. I hope the sound is better now. You can see I put the mic back. I'm sorry the sound was bad in the last couple of videos. Looks like this is why the podcasters are talking into the mic like this. Not because it's nice and shiny, but because that's the only way you can actually hear something. So today we're going to have a short lesson about dissolving. So you will see once we start talking about serious chemistry that mostly when we're calculating something, when we're working on something specific, it's mostly going to be dissolved in water. And water is a very special compound. Why? Because water can form hydrogen bonds, it can also form dipole-dipole bonds, it can also form van der Waals attractions. So water is something that actually very easily interacts with anything. And to make this short, for those of you who already know a bunch of stuff about this, anything that the water can interact with will dissolve in water. Dissolving in itself is not a chemical reaction. It's not technically considered a chemical reaction. Why? Because when you dissolve something, when you put salt or sugar into the water, it disappears, right? It dissolves. But after you remove the water, the sugar comes back. So that's why this is not really considered a chemical reaction. Although there is breaking of the bonds, there are some scientists who would classify this as a chemical reaction, but technically speaking, not. So how do you know if something dissolves in water? First of all, we know a bunch of these things from everyday life. For example, these here, metals, transition metals, they don't dissolve in water. Why? Well, again, water is a dipole. So water will react with other dipoles or with something that has a hydrogen bond or some kind of charge. However, as we know, transition metals make metallic bonds, which means the d orbitals of all of the atoms are overlapping and the electrons are everywhere, so the charge is equally spread throughout the metal. That's why water has basically nothing to stick on in a metal. However, let's see what the situation is for ionic bonds. So this is a simple representation of a lattice. Let's say this is salt. So a salt has no potential to form a hydrogen bond because it doesn't have hydrogen covalently bonded with oxygen, chlorine, fluorine, or nitrogen. But it does have these pluses and minuses. So what happens now? A water dipole looks like this. This is a water dipole. So one side is negative, one side is positive. So what will happen when you put something ionic into the water? So basically what will happen is the dipoles, the water dipoles will surround different parts of a lattice with the appropriate side of them. So basically they will come with a minus here and surround the plus. They will surround it actually completely because water molecules are pretty nimble. And if there is enough water, that's why, remember, when you put salt into water, it dissolves until you put too much. So if there is enough water, what will happen is the water will split this out. So you will end up having this plus and surrounded by basically molecules of water around it. So the pluses and minuses will be split out like this. And again, the minus will be here, surrounded by water molecules in the same way. This is now considered dissolved because the ionic bonds have been broken and this is spread out through the water. So ionic compounds do dissolve. Now, if we consider something that has a hydrogen bond, see, this is ammonia, one molecule ammonia bonded with the other molecule of ammonia with a hydrogen bond. Remember, ammonia also has dipole-dipole and also has van der Waals or London, but we're now considering the hydrogen bond. So again, what will happen now, the water has a bigger potential to form hydrogen bond. And if there is enough water, since usually when you dissolve something into a solvent, that solvent is in excess. There is a lot more water than there is ammonia. So basically the water molecules will come in here in a much bigger quantity than you have these ammonias, and then they will basically take away this hydrogen bond. They'll take it away, and then they will form hydrogen bonds with each of these two molecules of ammonia separately, thus dissolving them. So things that form hydrogen bonds are really easy to dissolve, actually. So when something can form a hydrogen bond with water, then it's very, very easy to dissolve. Similar thing you have for dipoles. Let's say this is a dipole. This can also be ammonia, so one side is negative, one side is positive. So again, if you put this into the water and if you assume the water is the solvent, so there's way more water than these dipoles, then the water molecules will surround the plus side with their own minus side like this, and they will surround the minus side with their own plus side like this. And again, when there is enough of them, they will basically break these two apart and they will stay dissolved. They will be apart and surrounded by molecules of water. So to make a summary, ionic bonds dissolve because they have pluses and minuses. Anything that has a hydrogen, that can form a hydrogen bond with water, dissolves, and anything that is a dipole dissolves in water. However, if something is metallic, it cannot dissolve because there is nothing for the water to stick on. There is no possibility of hydrogen bond and there is no separation of charge. Same thing with something which is non-polar. If something is non-polar, it is bonded only by van der Waals bonds. So the water can connect with it, but this is not considered to be highly soluble. In truth, it is very iffy to even talk about it for a high level chemistry and competition. We do not say something is insoluble in water. We say something is more or less soluble or more or less able to dissolve in water. We don't really use terms something cannot dissolve. We use the term something is more able to dissolve in water or less able to dissolve in water. And again, remember the terms solubility, dissolving, and insoluble, which is again something you don't want to use much. Hey, do the quiz. See you soon.